Welcome to my presentation. In this presentation, let us see how we can define the determinant. So let me explain that. If A is a matrix, if A is a square matrix, and if the elements of this square matrix are as follows, if the elements are A11, A12, A13, all the way to A1n, and then A21 in the second row, A21, A22, let me write these twos a little bit more clear. Let me write the second row again, A21, A22, A23, all the way to A2n, and then if we were to expand it all the way to AM1, AM2, AM3, all the way to AMN, like that. If that is a square matrix, and if this size is m by n, it has m rows and n columns, m rows and n columns, then the determinant of A is the sum of the entries in the first row of matrix A multiplied by the cofactors. So let me explain that. So then the determinant can be written out as follows. Then the determinant, which is represented like that, det of A, or sometimes also written out as A with two lines on the side, can be written out as summation. This is the Greek letter called sigma, summation. It represents summation. J is equal to I to n, and then here we have A1j, C1j, I'm sorry, not I, this is C1j, like that. Therefore, this is the first row and then jth column, first row, jth column. Okay, so we can expand this as follows. We can write this one as A11. We take the first row, first column element, multiply to the cofactors of the first row, first column element, plus A12, C12, plus all the way to the number of rows we have, the number of columns we have, A1n, C1n, like that. Okay, so that is how we can define the determinant of a matrix. Okay, that said, if we were to expand, find the determinant by expanding the rows, we can write that as follows. The determinant of A, the same matrix, the matrix which we have been talking about, we can write that as the determinant of A is, we can also represent it as follows, is equal to summation of J equals to 1 through n, Aij, Cij, and if we were to expand it based on the row expansion, based on the ith row expansion, we can expand it as follows. This is going to be Ai1, Ci1 plus A12, C12 plus this is AI2, CI2, and then this is going to be plus AIN, CIN. This is based on the ith row expansion. Ith row expansion. We can do the similar thing with the Jth column expansion. And how do we write that? Let me explain that here. So if we were to take the same matrix A, and if we want to find the determinant, and this time if we want the Jth column expansion, we can write that out as follows. Determinant of A, also represented as A with two lines on either side, is equal to summation of I is equal to 1 through n this time, A I j C I j, and this time the way we can expand that by Jth column expansion is as follows. That is going to be A1j C1j plus A2j C2j plus all the way to ANJ CNJ, and this is as per the Jth column expansion. This is as per Jth column expansion. We will see some examples using the row expansion and then using the column expansion to find the determinant of a matrix. In my next presentation, we shall look at examples to see examples related to row expansion and column expansion of determining the determinant of a matrix.